Number 5. A llama rancher has 600 yards of fencing to enclose a rectangular corral bordered on one side by the Rappahannock River. And we want to figure out what are the dimensions of the rectangle. And it looks like it's already been noted for us in this picture. The length of the fence is X and the depth of the fence from the edge to the river is Y. What dimensions should be used so that the enclosed area will be maximized? Right away, maximizing area. And in this case, area is set up to be variables of X times Y. When we talk about the equation for substitution to eliminate a variable and make this just an area in terms of X, it looks like it's going to have to do with the amount of fencing that it takes to make that corral. Now, assuming that llamas aren't going to jump into the water and swim to get out, we're going to assume that we don't need to count the water, and instead, the amount of fencing, that 600 yards of fencing, is going to be just taken up by the X length plus 2 Y lengths of fence. Not a total perimeter, but just 3 sides of that fencing. And so, typically we've been eliminating our Y value. So let's take that equation and manipulate it so that we have 600 minus X divided by 2 would eliminate our Y variable. So if we rewrite our area equation now, we can write it as X times 600 minus X over 2. And when you ask about simplifying to take a derivative, I suggest that not only do we distribute our X, but we also distribute that divide by 2. We can break that fraction up inside the parentheses because it's a monomial denominator. So I'm going to do 2 things. I'm going to distribute the X in and divide by 2. So I've got 300X minus that 1/2 from the divide by 2 X squared, just to make our derivative more easy. And also, really convenient for setting our derivative equal to 0 for the critical value. Our length of our fence, our critical value of X is 300. Second derivative test? Looks like it might be easy. Second derivative from our first derivative of A, our A prime, is easy. Second derivative is -1. Now what does that mean? That means that everywhere, since we have no X here to plug in, that means that everywhere, and you've seen this and you were afraid of it before, that upside down A, for all X values, no matter what they are, we have a concave down function. And so, right away, I don't care what the critical value is, it is a maximum, because the entire function, that quadratic, that area function, is an upside down parabola. So yeah, clearly the one critical value is going to yield a maximum. So we can go right to our solution now, or our analysis of the question, and answering what dimensions should be used so that the enclosed area is maximized. So maximum area will be found if X is equal to 300, and then the Y value of that fencing comes from the substitution equation. And so let's see up here. If we have a 600 minus 300 over 2, our Y value is going to be equal to 150. And this is yards. So the area of the penned-in area is going to be a 150 yards to the river and 300 yards across. Ta-da! That was a fast one. If you text me or email me about this problem, I'll have a treat for you when I get back.